Hi guys, this is Mr. Vandergriff, and I want to go over the engineering and design process. So you can see here the first step is you want to define the problem. You want to identify the criteria and the constraints. And then after that, you want to brainstorm ideas. You want to gather all your possible solutions. So where you can do some research on the internet, collaborate with your classmates, and then you want to come up with a plan to evaluate your ideas and then choose one and then go for that one plan, that design. And then from there, you're going to build. You're going to use your materials and you're going to build what you planned that was going to be a solution to the problem that you're trying to solve. And then from there, you're going to test. And then you're going to either test, and if it's not what you want, you're going to redesign and test or redesign and test. And you're going to be in this kind of iterative testing loop. And then finally you're going to get a product that you're happy with, and then that would go over to the share and then with others, and then you would critique and then improve that design. So a great example would be the iPhone or the cell phone right here. I had this first phone, an iPhone 3, but it's come a long way since 2007. And you can see it's getting thinner, it's getting taller, there's more pixels, just been improving the sound and the speed, all of that. I remember this first phone, I think it had a couple games like Angry Birds and Cut the Rope, and then didn't even have Siri or video camera or anything like that. And then now it's just amazing. Face recognition and all the other things that the phone can do. It just literally is a powerful computer in your pocket. This also design engineering processes and used in space, as with SpaceX with their Falcon 9 rocket. You can see here that a lot of times when we launch rockets, these boosters, they just become space junk or fall back to the Earth. But Elon Musk at SpaceX is like, we could save at least $10 to $15 million if we could recycle that. So let's figure out a way to do this. And he figured out he could use drone ships. This one's called, Of Course I Still Love You. And instead of having to come all the way back to the land, they can land in the middle of the ocean. They use less fuel. And so they tried over and over and over. But their designs were not successful. First he's trying to land on the drone ship. Then again, they tried. Looks like they had a successful landing right here. Everything pretty excited. And then actually quit. Take a look. Again, you're looking at about $13 million just exploding there. But finally, they did have some success with it landing with the another iteration of the rocket. It landed successfully. You can see it's just a little off of its target. That's pretty amazing. People thought this would be impossible to do. Here's actually a little video clip of the first time that it ever landed, the Falcon 9 rocket, successfully.
So right now, we just got confirmation that the landing burn has started. Let's take a look at the drone ship now. So you're seeing live footage of Course I Still Love You, our drone ship, waiting for there's the engine. Slow it down, lights are deployed.
Pretty incredible. So now SpaceX has been working with their Starship. This is the ship that they plan on going to Mars with. It can hold anywhere from 90 to 100 people, and they want to send these ships ahead of time before humans get there with supplies and food and fuel and medicine and vehicles, and then send the first ship. And if you haven't heard already, that this is what the Starship looks like, and you can see that this was just a couple months ago. Some spectators were videoing. You can see it taking off here. I believe this is in Texas. It's just unbelievable. That thing is massive. It's like a giant cylinder that, again, can hold almost 100 people and supplies. Pretty cool. And now, then it turns and it starts to fall back to Earth. The retro rockets kick in, and that's slowly supposed to stop and land, but obviously that one didn't. But after about 15 different iterations in the last couple months, they were successful. Here it's taking off. then you can see as it gets to a certain altitude, it starts to cut the engines out and fall back to Earth. And then it swings around and hits the retro rockets. Successfully landed the rocket back to Earth, the Starship. And this is really cool because in the next 2 years with the Artemis project, SpaceX has, I think they were the one that won the prototype. So they won the contract to make this lunar landing on the moon. So they will be landing there in probably about 2 years. This just gives you an idea of the size of what they're going to be landing on the moon compared to what we first landed, the Apollo lunar landing in 1969. Very, very, very tiny compared to what we're going to be landing on there in the next couple years. Here's some past engineering projects. We've done the Marshmallow Tower, again, where you work together with your partners, you come up with a plan, you brainstorm, and then you actually put that solution together. The challenge is to build the tallest marshmallow tower freestanding. It looks pretty easy until you get that marshmallow on top. You've got a certain criteria with a certain amount of spaghetti and string and masking tape. Here are a couple successful towers. Another project we did using the engineering design process was designing a helmet and was testing for compression and tension and gravity. So here is a helmet, but actually it looks like the egg came right out of the helmet, and that was devastating. So then the next iteration, they actually strapped in the helmet with a little chin strap that's supposed to represent your head, and I think this was successful. Let's take a look. Landed, and this iteration, yes. Well, no, this one was not. So again, back to the drawing board. Let's take a look at what they have to say here. They're brainstorming an idea.
Memory foam or styrofoam? The styrofoam?
I think the styrofoam would break that height up.
Yeah, I could. So for Marcella's we said memory foam, and then yours styrofoam.
The whole idea is to listen to everyone's ideas and not put anyone down. So when you're collaborating, because you never know, some crazy idea might just work. Like so many people said that Elon Musk was absolutely crazy to think he could land one of these boosters back on Earth, but he's doing it and making space flights so much cheaper doing this, and just Mars that much closer. So I want to apply the design engineering project to the toothpick water tower project. And so again, you're going to be using the design engineering process. Here's many different designs of water tower designs in the past. So the first thing is you're going to research. You're going to go on the internet and look up ideas of toothpick towers, toothpick bridges, water towers, and then in your science notebook, write all those down and then brainstorm ideas with those people, at home, brother, sister, grandpa, grandma, mom, dad, just family members, and coming up with ideas. And then you're going to come up with some blueprints. So here are some students that were doing the Toothpick Tower project, and they're doing research. They're writing their ideas down on sticky notes. They're writing on the glass. They're writing on the whiteboards. Listen to this little collaboration right here. I think this is this is John.
That's amazing handwriting out there.
Okay, stop. I was reading the one instructions.
All right, talk to us. What do we think? John, what do we got here? What'd you write?
When I was in elementary school at my old school, we did something about this when we were learning about bone structure, and there were two designs that I did because we did something like this but out of a single sheet of paper. And there's two designs that I made that were the best. It was a cylinder over here and then a triangular prism, so it's a triangle with square sides on it.
You think it's possible to make a cylinder out of toothpicks?
I don't think it would be a perfect cylinder per se, but you'd use a heck of a lot of toothpicks, and I don't think it would be a good weight.
Yeah.
So I think this, at this point, would be the better with toothpicks.
So the whole idea is obviously to work together. Again, with COVID going on, makes it difficult. But again, Now that we can be 3 feet apart, we still got our masks on. You can still collaborate with the people at your table and at least hold up your ideas. So we're not going to do the sticky notes and the whiteboard like I'd like to do in the design process, where you share with 3 other people, you get your sticky notes, you look for similarities, and you look for differences. You start to categorize your designs, and then you come up with an optimal best design as a group. And because of COVID, we can't use the sticky notes and the whiteboards, but we'll do a similar version of this in a safe manner in class. And then also you could be doing this at home with family members and having discussions and brainstorming ideas of which would be the optimal design for your toothpick water tower. Hopefully you found this video helpful.